Introduction to solving trig equations. Let's think about what it would mean to solve a trig equation. So look at example A. Sine of x equals 0.62. Now we know that the x must represent an angle. Angles go into trig functions. And the 0.62 is the ratio, the number that comes out. So I want to find what angle would I stick into the sine function that would lead to a ratio of 0.62. Well, that turns out to be a little more complicated than you might think. I've got the graph of the sine function over here. The ratios, of course, are here on the y-axis. Here's 0.5, you can see 1 right here. 0.62 then would be somewhere around here. Well, I want to know an angle that leads to that ratio. Here's the problem. There's tons of them. There's one right here. There's another one right here. There's more on this side and here, and you know this graph goes on forever in both directions, which means there's an infinite number of angles. All of these angles that we just marked lead to that ratio of 0.62. Trig equations tend to have an infinite number of solutions, unless there's a restriction given. And that's what we have here. Notice we're not being asked to find all the solutions. We're only being asked to find ones between negative pi over 2 and pi over 2. Now that interval was chosen purposely because that is the restricted zone for the inverse sine function. Negative pi over 2 to pi over 2 would be this section of the graph, and in that particular section there is only one angle that leads to a sine ratio of 0.62. Well, that's the one angle we want to find, and the thing is, since we've chosen the restricted zone, I can simply use the inverse sine function to find my answer. In other words, that angle I'm looking for is the inverse sine of 0.62. This means the angle within the restricted zone whose sine ratio is 0.62, and that's exactly what I'm looking for. Obviously, I can get the value right off the calculator. Just go to sine inverse, type 0.62, and you've got it. The angle in question is about 0.6687 radians. Now, obviously, if I had wanted the answer in degrees, I would have just gone to the calculator, changed into degree mode, and redone the problem that way. I'll use the entry button above enter to recopy that last expression we typed in, hit enter, and now I'm getting the answer in degrees, about 38.3 degrees. We wanted the radian answer, so I've written that here. We're saying that is this angle, the angle within that restricted zone that leads to a sine ratio of 0.62. Let's look now at part B. Now this is obviously a little bit more of a complicated equation. I will point out at the beginning, notice the restriction. It's the restriction for the inverse cosine function, 0 to pi. That's good. We'll use that to our benefit a little bit later. But the first thing I'm going to have to do is clean this up a little bit. It's too complicated right now. Let's subtract 4, and then we better divide both sides by 5. And then remember, cosine squared x means the entire cosine x is being squared. I would like to just have this say cosine x equals, so to get rid of the squared, I'll square root each side. Remember that when you square root both sides of an equation, you must include the plus or minus. That's interesting because it means I end up with two results here. Cosine x equals positive or negative square root of 4/5. I can simplify that. Square root of 4 is 2. Square root of 5 does not simplify. I'm not going to worry about rationalizing that. This is not any kind of final answer. So where do I go now? Well, let's remember what we're doing. I'm looking for an angle. Angles go into the cosine function. I'm looking for an angle in the restricted zone whose cosine ratio is either positive 2 over root 5 or negative 2 over root 5. I think I'm going to have two answers here. Let's see, I'm only looking between 0 and pi. Well, in the first quadrant, I can certainly find an angle whose cosine ratio is 2 over square root of 5. In the second quadrant, that's still in my zone, 0 to pi, I can find an angle that has a cosine ratio of -2 over the square root of 5. Right? Cosine is adjacent over hypotenuse. So I have this first quadrant angle, and I also have this second quadrant angle. I can find those two angles easily by using the cosine inverse function. Cosine inverse knows about angles within that zone. So the first x value would be cosine inverse of +2 over the square root of 5. And the second x value, of course, would be cosine inverse of -2 over the square root of 5. Again, we can find the values right on the calculator. Let me put myself back in radian mode and quit out of there. And then we had cosine inverse 2 divided by the square root of 5. Don't forget to arrow out of the square root. So there's my first quadrant angle in radians, about 0.464 radians. I'll use that entry button again, and then I'm going to go back into this. I just want to change it to a -2, so I will insert. Insert is here in blue. I'm going to insert a negative sign, and now I have cosine inverse -2 over the square root of 5. Here's my second quadrant angle, about 2.678 radians. So because of the plus or minus, we ended up with two solutions to that equation. Finally, let's take a look at -4 sine x is equal to -40. Once again, I'll clean it up by dividing both sides by -4. That gives me sine x equals 10. So I'm being instructed to find an angle in the restricted zone for inverse sine whose sine ratio is 10. Well, as soon as you see that, you should realize we've got big problems here. There's no such thing as a sine ratio of 10. The highest sine ratio is 1. This is an impossible equation, which means it has no solution. Sine ratios only exist between -1 and 1. Thanks for watching.